Okay, thanks. So actually going back to shortly after the class was started, and it was really Jim Pinkovich from Gosman and Moore at the time, or no, Hulberg. Jim Pinkovich and Jim used to be with Mashad Cooley. He had left us and went to Hulberg, but they got involved with that commercial project. And I had been heavily involved with the class and saw that and said, okay, we got to get involved too. So I chatted with the instructor. Okay, Mashad Cooley wants to also sponsor a class. So we jumped on this industrial project. Our industrial experience is not the heavy smokestack, big machinery. We're not doing that sort of industrial project design, but we have been and are involved with industrial projects more in the medical manufacturing. So what I chose to do was sort of model a project we had recently finished, 15, 16 years ago now, for Boston Scientific out in Maple Grove. And it had some research labs, and it had medical manufacturing capabilities where they manufacture their product. And so that's what I chose. It is industrial, but it's a little bit light industrial and more medical manufacturing. So that's the project that we chose to model. And I'm looking at the outline, and maybe the years have passed where I got a little bit casual. I have updated some things from time to time, but as I reread it, I think we may throw some, maybe we'll call them some addendums into the mix here. So there's a few things that I might want to change. So start off with it as written. I might mention some of the areas that I'm thinking of changing, but we'll get that officially via email to Chad so you're up to date. So why don't you go back to that floor plan again there, Chad, for a second, and just kind of the highlights of the project. And as it states, it's 15,800 square feet of building on the first floor, and we've created what we anticipate as a back area with more of a equipment space, generators, electrical room, and then we move into mechanical equipment room, hazardous material space, and we've thrown that in. And actually, we have had hazardous material requirements at Boston Scientific, and so it's a good thing to kind of expose yourselves to. Not the entire facility had that, but they had special rooms where they handle some very toxic and hazardous explosive materials in barrels, and they bring it out and use it in quantities. We're doing the entire room, I think, per my document, and we've done entire rooms at Boston Scientific. But we've also have sharpened a pencil and used a localized hazardous approach, where the whole room is sort of normal, but then you have hazardous zones with some equipment here or some equipment here. And it's a little bit unique, but for this exercise, we'll treat the whole room as a hazardous area. And kind of the rest of the first floor, this is sort of, in my mind, the heart of the industrial piece, if you will. So all of these components represent different manufacturing pieces of equipment, and we have an equipment list attached at the back of the document that gives you the power requirements. So as part of the design of this facility, you need to know, the loads and the locations, and as part of your design, you need to get power to all of that equipment within the manufacturing space. We've included a data center. Mashad does a lot of data center work, and in fact, for about the last 6-7 years, I've been heading up the mission critical group within Mashad Cooley. So my focus has become more data center focused as opposed to the Boston Scientific. We still work with Boston Scientific, but I'm less involved than in years past. But the data center is a big part of what we do, and it's an important thing to consider. Moving down, a little office support space, a little UPS room for the data center. I'll talk a little more about that in a minute. And then, of course, maybe where I should have started, coming into the building with a waiting area, kind of reception, some support spaces, and then an elevator brings us up to the second floor. So why don't you grab the second floor quick.
course, it has to be the last one.
Glad I'm not driving that, we'd never get done.
There you go.
And so as you can see, the manufacturing space is really a two-story space. So the lighting will be up at the higher level. I talk in the document about bus duct, so that could be at a higher level. Doesn't necessarily have to be the highest level. That's something for you to consider. But we need to feed the equipment. So again, that being a two-story space. This also shows as not a two-story space. Thanks. That's a roof. So that's. But if you need it to be, you know, and we're not really getting into the necessarily architectural, but it might be a little bit higher than the single-story space if the gen set and the gear wanted that roof to be higher. We could make it higher. But we don't have to make it match the second-story space to save it some money. So okay, up on the second level, we're looking at big air handling equipment that would feed ductwork. We're not showing the ductwork or the air handling distribution, but we are showing the mechanical equipment that feeds that, and the mechanical equipment schedule shows the power requirements for that equipment. And I think over here I wanted to introduce, because most of our medical manufacturing facilities have some sort of research lab. So these are lab benches, if it's not clear by the picture. So the lab bench is, you know, stand up, work at the lab bench. There may be some plug strip on both sides, and the center might raise up so you could have stuff at the lab bench working both sides. So that's what these are, is lab benches. I think we talk about what we'd like to see for power at the lab benches. And this I just introduced as a specialized environmental chamber that has a certain power requirement. So just kind of throwing in these special walk-in chambers that could cool or heat or provide a particular environment for part of their research activity. So we threw that into the mix. So what we got down here, a kind of a breakout room, vending equipment, sink, refrigerator, microwave, coffee pot. So some basic comfortable lighting and casual area to kick back and take a break from time to time. So that's probably a high level of what this building is. And haven't made a lot of architectural changes. Back in the beginning, some of the folks were kind of tuned into some of the general building requirements and caught us on some building code violations. So, I mean, if you see anything that you think is a building code violation, bring it to my attention. We'll fix it. But can't guarantee that we comply with the building codes. But we think it's a representative of what we're trying to model. Okay, so back on the narrative, phone system, I think we call for in the document some phone devices, but we're not asking you to design the phone system to show the provisions. So I, the owner, will provide the cable and phone instrumentation. So that's not something you have to worry about. Same with, again, with the data and network cables. We're asking for provisions. There's a list of codes that we need to comply with, and does anybody know if my code list is current or not? Probably not. The Minnesota does not use the UBC any longer. Minnesota codes refer to the IBC, the International Building Code. So Minnesota has adopted the International Building Code as our code standard, and we no longer follow the UBC. And Minnesota does have amendments to the IBC, which become part of Minnesota State Code. So just an FYI, we'll change that next official printing. Talking about the electrical service, looking at a pad mount transformer. Do you have a site quick, or is that not clear?
Yep, no, it's
Testing you. Maybe 3D probably work. So anyway, the electrical room back here, you know, wherever you end up putting your main electrical service, the utility will need to have truck access to a pad mount transformer. So you're going to have a pad mount transformer outside where the utility will bring their medium voltage, 13,800 volt here in our territory. So they'll bring that to the pad mount transformer. They furnish the pad mount transformer. You connect to it and bring in the secondary service into our building and into our main switchboard. and we'll be bringing in 480, 277 three-phase 4-wire power. I mentioned that we're making this more industrial, and so the switchgear being UL 1558 is important. It's more robust gear. It's compartmentalized, big power system circuit breakers. You're probably familiar with the molded case breakers you might have used at the switchboard for the commercial building. This is more industrial in nature. The 1558 breakers, again, have individual compartments for each breaker. I'm asking for the breakers to be draw out. That means you can turn this breaker off. You can open the door, unlatch it, and crank that breaker out for periodic bench testing and checking the tripping of that breaker. And then once it's tested and recertified, you can slide it back in and punch it back in. And so it simplifies maintenance or repair if there's a problem at that switchboard. It's more expensive, takes more room, but in an industrial setting and even in our data center settings, that's what we're requiring for speed of repair, replacement, speed of maintenance, and speed of recovery if there is a failure. So I'm requiring that. Something to think about. I don't know that I say it, but as you start to investigate the kind of breakers and kind of big switchboard that's required, this is going to need to be front and rear accessible. So you're not going to be able to slide this up against the wall. It's going to be 72 plus or minus inches deep, and it's going to require rear access. So it's big gear. So keep that in mind. Let's see here. When I talk about just some of the general pieces, we're going to have some 277 40-volt lighting panels. So the lighting will likely be 277. If you choose to do 480 someplace, that's your call. If you feel it's justified, but at least be likely 277. Then we have 122.8-volt transformers feeding panels for all our light circuit needs and receptacle needs. We're looking at feeding bus duct when I need the 122.8 equipment, and much of the equipment is 122.8. So I'm looking at providing a 122.8-volt system with its own transformer from my service to feed that 122.8-volt equipment. And so that transformer, like these other items I've talked about, would be loads that I'm expecting to feed directly from that main electrical distribution switchboard. Electric chiller, we expect to go right to the switchboard. And then I'm looking at some 277 480-volt bus duct that again would supply the 480-volt equipment within that space. And I am suggesting that you can apply an 80% demand factor on the equipment in this equipment list as you get involved with your design. And then we'll have some mechanical equipment distribution boards going back to the switchboard. Talking about closed transition feed to parallel the generator, the electric service switch and the breaker for the parallel generator will be electrically operated and controlled by the paralleling gear. So what does that mean? We've talked about...
You can draw on that thing.
Here?
Yeah. Grab the...
This stuff?
No, with that, with these.
Well, I'll draw this. This is probably simple enough.
That's all right.
Your commercial project, you had an automatic, automatic transfer switch that went to the generator, and it went to the utility feed, and then it had the that's better. So at some point we have an automatic transfer switch. It gets a generator source, and it gets a normal source, and then here's my load. That's my emergency power. That's my ATS, and that'll come up again a little bit later because I need an ATS for my required life safety loads in this building. So I'll have a ATS for that. But what I'm talking about here is within my switchboard, I'll just draw it simple. Maybe my initial cube might have a large circuit breaker, and then maybe in the next cube, I might have a large circuit breaker. This may go to the gen. This may go to my utility. So I have paralleling equipment controls within this board that looks at the generator and looks at the utility. So normally, of course, I'm running on utility, generator's not running. This breaker's closed, this breaker's open, and life is good. Utility fails, the gear senses utility failure, it opens up this breaker, starts up the genset, where the genset comes up to voltage and sine wave, it closes the breaker, and everything comes back. But what I'm asking for is a closed transition transfer. Let's say there's a reason that we need to do some maintenance on this breaker. So I can go up to my controls on a closed transition and say make a closed transition transfer on the generator, because I need to have access to this breaker. So it'll fire up the generator, and it'll look at the generator sine wave, and it'll look at the utility sine wave. And when it'll kind of control the generator to the point that the generator sine wave is in sync with utility. And once my generator and my utility are in sync on their output, it will close, and that's a closed transition. So once I close on the utility, it kind of I can do a soft transfer where I can change the impedance of the genset so that my loads can slowly ramp onto the genset. Once I have my load on the genset, then I open my utility. So that's a closed transition transfer on the genset. Now I have access to this breaker, as I mentioned before, to draw out. I could unlatch it, draw it out, pull it out, bench test it, get it recertified, recalibrated, put it back in, and then do a closed transition back to my utility. So that's the kind of gear I'm asking for, and those are the kind of requirements I'm looking for as you start to look at the power gear. Okay, emergency power requirements. Sort of touched on that a little bit. We have an emergency generator on this building to serve both my life safety, so that's my code required egress exit lighting, and also to support 100% of my building power. So I've already talked about the fact that this genset needs to support my entire building, so my building loads, whatever I might need, and these will also be draw out, but I can likely get, depending on their size, 2 or 3 per section to feed my other loads. These are also draw out breakers. So I got my entire building on generator, but now I've got to deal with my life safety. So what you're probably going to be looking at is for my genset, here's my code required off my UL listed for life safety automatic transfer switch that feeds a panel that's dedicated to life safety loads. That's my life safety pathway. And then I have the building switchboard that's supported by the same genset, but that will support the entire loads. So that's what I'm looking for in terms of the emergency power in this section. Okay. Transient voltage surge suppression I'm also looking for, but that'll be at the main service.
But ahead of
At the main?
yeah, where is it?
It's probably not ahead of the main, because we usually need a. Oftentimes, I kind of like it in the board. Some people don't. Some people argue it should be out of the board. The people who make the boards argue it should be in the board, of course. People who don't make the boards argue that it should be outside the board. Either way, the busing in the switchboard, I want to minimize my distance to my phase, neutral, and ground for my TVSS. I kind of like it in the board, but we still usually want a breaker oftentimes to feed that TVSS. Sometimes it's built into the TVSS, sometimes it's a breaker in the board. I didn't say, I don't think I said in or out, but I'll kind of leave it to your choice on that one. But so if it's in the board, it literally gets built with the switchboard, makes for clean. If it's not on the board, then you might mount it on top to keep these leads short, because the longer these leads are, the less effective the performance of the transient voltage surge suppression. So we really want to keep those leads as short as possible. And oftentimes I've seen this over here on the next wall, and you got 25 feet of wire. It's pretty well useless in terms of being able to be a transient voltage surge suppression device. There's just too much line impedance between the busing that's trying to protect and the the component of the other wall. Okay. These are just general power requirements. I think they're just, I don't know that we have anything that's too unusual, but just looking for some general criteria for receptacle placement. I think that's fairly straightforward. Design criteria here. Talking about duplex receptacles within each area scheduled, so we already went through that. 4 outlets to be provided in the waiting area to service island reception desk. Kind of talk about that. Power for my data center. Let's go back to that. That's item C. And I showed you the data center, and I showed you the UPS room. And I was asking for 15 minutes of UPS support for the equipment in that data center. Let's look at that data center plan just for a second, if we can, Chad. First floor. First floor. Okay, I'm kind of focusing on the data center, and we'll catch that UPS from down here. So, what these represent, now if I wrote on this one,
Nothing. It will write.
and you'll make it go away? Okay. There's really probably no line here in today's computer racks. Back when we started this, computer equipment was a little bit different, a little bit more like small wash machines that were back to back and lined up row after row. But, what we're seeing today is a rack that's probably roughly 2 feet by 4 feet deep. And so we're looking at racks kind of facing each other. This may be the front side, the back side. And I probably could do a different data center design, but we'll live with this. So if this is my front today, the rack, I don't know if you have been in a data center, we will get you a chance to get in one. So there's multiple servers, kind of the horizontal server, not unlike these PCs, that are located within that rack. And air goes in the front and out the back. And so this is what we call a cold aisle. So the perf tiles in the floor of this raised floor would be in the cold aisle. So we dump this aisle space full of cold air, and that puts the cold air through the racks into what we call a hot aisle. And then if this is dumping air out here, this also has to be hot, so then this side over here would be cold. And that's how we would be designing this, so that the front facing is in the cold aisle. What we're also seeing today is, with this kind of construction, we're seeing any typically 5 to 10 kW might exist in this rack, but we're seeing racks today of 12 to 20, and even they could be greater than that. kW within a 2 foot by 4 foot rack. That's becoming a lot of power within this rack. So, one thing I'm going to change is my watt density of my data center. For years, I said 30 watts a square foot. That kind of dates how long ago I've updated this particular item on my document. So we're going to go from 30 watts per square foot, and we'll bring her up to 150. I haven't done the math. I don't know how that impacts my service. If you find that I'm at a threshold and it's going to cause some really crazy things at my service, give me some feedback as a designer and say, this X thousand amp service, if I bump this up to 150, I need, I can't get any bigger. I need two smaller ones. If you live with 100, I'll be okay. So we'll try to make this work, but if you see a big problem, let's talk about it. Maybe we'll adjust that.
How do we go about counting the number of PDUs that are?
Well, the
Pretty
PDUs,
strictly off of square footage.
yeah, I probably should have thought this through before, but this is kind of on the fly, so you guys have to help with this. The PDUs, and I don't know that we'll.
You can use different colors.
Yeah. So we're going to have, here's where I'm going to get in trouble. And as designers, you may have to come back and tell me that I'm going to lose some office space because my UPSs might have gotten bigger. So when you look at the UPS requirements and look at their sizing requirements and their layout requirements, if I need to lose a couple office cubes, I'm okay with that. My data center is becoming more important. So if you need to make that change, show me that we need to make this room bigger to get bigger UPSs in. So I'm not telling you what those sizes are, but I'm guessing when I make them big enough to handle 150 watts a square foot. And I'm going to talk about the entire raised floor area, which will include some battery. My raised floor area is this whole space. So we get information different ways from our IT folks, and sometimes we just need to guess. Well, that's a bad word. We never guess. Sometimes we need to try to take the best available information that we can get from our IT folks and then feed it back to them and suggest that a density of such and such would service their needs as they've explained it to us. And that's close sometimes to a guess. But folks in IT group who are very sophisticated, they can give me a list of the racks and what I get if they know what they're doing, and some do. They're going to give me this whole row thing, and they're going to suggest that when they fill this rack up, it's 8 kW. And then this one is 6, 6, 6, 6, and I got a bunch of 8s. So then we can go through and really build the capacity of that data center. And what they give me might only be, these two rows, and that's future growth. So we'll kind of, average this or say, well, what's your future going to be? Is it going to be more this equipment? Or we got a couple blade servers here at 12. No, we're going to be more of a blade farm. Okay, so maybe we allow 12 over here. I'm not asking you to kind of dissect the data center. I'm telling you that my average is 150 watts a square foot. And that's the load I want to be able to supply on the floor, no matter what the individual guys need. I want to be able to give 150 watts a square foot on the floor, so we need to upsize my UPSs a little bit so they can handle that. How does this one get?
I kind of misspoke. I'm reading the thing, 220 amp circuits with each server cabinet.
Yeah, I'll get.
Yeah, Guy, you might, when you pick them up, just put it back. Yeah, where the color coded, yep. And then every time you pick a color, put the other one back. That's how it works.
I'm confusing him.
So if you want a red now, pick up the red, they'll be red.
And I can make this red.
There you go, yeah. Sorry.
That's okay. I'll get to that. And I think I'll be okay. But what I've asked for and what I'm going to change is for each server rack, I need 2 whips to my PDUs. And so each of those whips, I think I'm going to now say, if I have to change this, I will, but I think I'll be okay. I'm saying the whips would be 30 amp, 3-phase, and don't need neutrals in my equipment, 3-wire, 208. So I need a whip from my red PDU and a whip from my blue PDU to each rack with 30 amp, 3-phase, 3-wire, 208. And within the rack, could have done that, red and blue. I'll have a
It was in the racer too.
red, I'll just pretend that's red, and blue vertical plug strip that then my whips will feed. Which one's the eraser?
Right there.
This?
Yep. I have to put it back to work. So, there we go.
And these are internal plug strips that are sitting, inside my rack. One from the red, one from the blue PDU. And I said 3-phase, 3-wire. So within, I'll have maybe a series of plugs, and there's going to be essentially 3 groups of I shouldn't say plugs, I should say receptacles. And I'll have the same thing so within these guys, actually they'll have a little 2-pole circuit breaker ahead of each of these groupings. So they get the power that I'm coming in, and on this grouping, they'll connect to phase AB, and maybe this group will connect to phase AC, and so this group will connect to phase BC. So I'm feeding 3-phase, 3-wire power to this strip, but I'm feeding 208-volt single phase to my server. So all of this is in there so that each and every server that's in that rack would then plug into the appropriate plug strip. We're actually, you can buy colored cords for your server. So sophisticated owners are buying blue and red, if that's our color choice, cords, taking the black ones, throwing away. And they put in a blue cord, and this has blue nameplate on it, and this has red nameplate on it, and this is blue seal tight, and this is red seal tight. So it's a real visual certainty that everything's plugged in right. Because the whole idea of this duality that I'm starting to show here, going all the way back through my PDUs to my UPSs, now in this job, it isn't a data center, but in this job, my duality ends back at my service. But until I get to my service, I have complete 2-end duality. Is that gone?
I think so.
You think so? Okay. That's all right. We had complete 2-end duality to the server. So I could have lost my whip, I could have lost the PDU, I could have lost my UPS, and all of the servers in that room would continue to be powered by their surviving power supply. So think of it as 2 cords to the one server. Let's say it's a 600-watt load at that one individual server. Each cord is carrying 300 watts because they both have a little power supply and they feed a common DC bus within that server. I unplug one cord, the other cord is now carrying 600 watts, and that DC bus didn't skip a beat. So we're maintaining power at that server, you know, if we lose a cord or lose the other cord. And then upstream, we're adding reliability by having 2 PDUs, so if a PDU goes down, all the equipment would still survive because the other PDU is hot. And we do the same thing at the UPS. So maybe, of course, data centers, my area of interest, so maybe I focus a little on that. But I want to make some changes here to what I've done over the last few years, and I'll get an email to Chad to kind of document the specifics. Okay, otherwise we talk about 120 208 volt bus duct to service the equipment in the manufacturing area. I mentioned that I want that to be plug-in type, and we'll have cord drops. One of the projects that we bring you to, and I've kind of handpicked these projects because I think they show different elements of what you'll see here. But one of the first projects we see is the Boston Scientific, and we'll see a manufacturing space which actually is not going to be too unlike this space. I mean, that was really what inspired me to create this as your project. So I think it's good to see in 3D how they handled that manufacturing space. We don't get to go too far into the manufacturing space, but they've got some viewing windows that they'll let us take a good look at. So then you'll see equipment served by bus duct, and we have 480 volt bus duct, and then we have 122.8, and you'll see some of that. I talked already about the hazardous materials. I make mention of the wire mold on the lab benches, manpower connections to environmental equipment. I mentioned that previously, and then we need power for our mechanical loads, the air handling equipment that we have shown. I'm probably missing a few pieces of mechanical equipment. I think we have a handful, but if we were to have a full design, there's probably other things that we didn't touch on. But I think what we have is representative. The owner's equipment list, again, shows the equipment that we have primarily in the manufacturing space. And then, again, a mechanical equipment list that we also show. Okay, lighting. I'm looking for some ideas. I mean, what we're showing here is lighting illumination levels and the basic type that we were looking for and the basic controls. We're not asking for a building-wide control panel with more localized controls for this one. We're probably using things that some of you may say that seemed a little dated, and probably is. So I think I'm, you know, as the owner, I'm going to be somewhat open if you have a better idea. Maybe you want to do center basket, or maybe you want to do, you know, maybe you want to do some direct, indirect in the office space. I'm open to having someone, you know, say I think there's a better way, and I think as long as it meets what I've defined as my light level requirements and controls, I'm sort of open to expand on that. And also, the HIDs, I'm open to other solutions in that manufacturing space. I mean, the HIDs were a pretty neat solution in its day, but I'm seeing going back to a cluster of fluorescents. I'm seeing possibly LED. I think as an owner, I don't know anything about lighting, and so I'm going to open up that solution to you folks. If you have a better idea, you know, give me better lighting levels, better environment, better energy. I'm open to other solutions other than the metal halide. So I can comment on that, but I'm not going to dictate as to what that solution should be. I think on some of these rooms, I'm just going to back away and say, you tell me what you'd recommend. So I'm, you know, kind of hoping I see a couple different solutions that might come up. If some test one, some test another, and then someone's going to get the low bid, I know. But whatever it takes, you know. I'd like to see a little bit of variety, perhaps, in some of the lighting solutions. So I'm thinking I should back away in a way to this as a direction. So I'll go through this, and Chad will give you an email to kind of suggests that we're open to
LEDs,
number of-
for example, there's a lot of LEDs.
I'd like to see LED considered. I really would, and I think the LED could be a solution, probably clearly for the parking lot and maybe even for the manufacturing area. So we'll open that up and look for some creativity in those areas. Lightning protection, kind of moving on a little bit. We're looking for a master label lightning protection system, and I think coming up here in a few weeks, you'll have Thompson Lightning in here making a presentation, and they're the experts that we rely on. So oftentimes we'll show a lightning protection system design in our drawing set, but that's not a real area of our total expertise. We understand it and we can kind of work our way around it, but we always have Thompson come in and help us through and help us make sure that we're not missing something that's necessary to get a actual master label system as we put our documents out. So they'll be a good resource for that. I'm asking for a paging system throughout and interface with the phone system, although we're not designing the phone system, we can have that interface. Recessed speakers in area in fitting spaces, and then horns in equipment spaces. And I think, is it next week we have someone from low voltage?
I believe so, the low voltage next
Yeah,
week.
so they'll be able to talk on paging, and we asked for a clock system. Not a lot of folks still use clock systems, especially with the advent of internet time, but they still exist, and we thought we'd just expose you to a centralized clock system. We may be pushing that one, but with the advent of internet, but I'm leaving it in. And also a fire alarm. We're asking for kind of what similar to what you guys did at the commercial project. Is it's not code required to have complete coverage, but we just like to have you do a little bit more work and just say. And if you do provide coverage in a building, if you choose to provide detection, well, then you have to provide code required coverage. You can't just throw in a detector here and a detector there. If you're going to put in detectors, you cross the line and you have to comply with full coverage. And so we're saying, go ahead, let's provide the full coverage in our building. And the computer room, I'm asking for a pre-action system, a pre-action sprinkler system. They can get more sophisticated than that, but I think we'll leave it at that for this one. Okay, smoke detectors, where we're calling then some technology raceway in the manufacturing, office space, and research lab. So we'll see that the manufacturing equipment needs some sort of control interface. So we're looking at some sort of technology cable management system in the manufacturing space, and then also in the office research lab. So that's the narrative, and that's our project. I've identified a few things that we're going to open up or change. With that, any questions?
Nothing touch on the material, the equipment is just listed equipment for you.
Yeah, and we identify whether it's a full voltage non-reversing starter or it's a VFD. VFDs in my world are bioelectrical. That's my world. Different offices do different things, and different offices do different things within the same office. But in my world, the VFD should be specified by electrical. There's too much harmonic issues to deal with. And in many shops, they say, well, it's simpler to let the mechanical require the VFD because then it kind of serves that motor. Well, there's really nothing magic about what that motor is. I mean, the motor has to be compatible with VFD. So that's all the mechanicals need to say is it's compatible with the VFD. But the VFDs, if we have a number of VFDs in a project, and we would model the electrical system, including the VFDs in projects like this in our power tools analysis, and we could look at the harmonic impact of the VFDs at different components, and we could then perhaps require a line reactor to help minimize the harmonic feedback into the system. But if it's really intense in a certain area, because we've got a bunch of VFDs off of this big distribution panel, and they're big VFDs, we may need to have a tuned harmonic filter. And we have done that on a number of our bigger projects where it's a 50, 7,500 horse motors kind of lined up. Now we need a specialty tuned harmonic filter next to the VFD to minimize the reflection of harmonic currents back into our building system, because the VFD is a kind of a harsh nonlinear load that reflects harmonics back into our system. And so again, I'm of the strong mindset that when electrical specifies the VFDs, we pay more attention, and we can better understand the impact of those drives in our system. And so those would be by the electrical contractor. And a exception to that, if you go back to the chiller, right here we're saying the starters by Division 15 mechanical. And I'm using the old-fashioned Division 15-16, but easier for me. Up till recently, those were probably starters that were mounted on the chiller. So it's starters by Division 15, makes sense. Now we're seeing the chiller manufacturers build a VFD so they can ramp up the chiller more gradually, and it's less inrush on our electrical system rather than banging on a 500 horsepower motor. So they ramp it up. That's a good thing, but we're still letting it be by the chiller guys because they build it back at Carrier or Train, and it just makes sense for them to provide it. And I would fully agree with that. When I'm modeling my power distribution system, I'm going to need to get cut sheets from my mechanical counterpart saying, give me the cut sheet on your chiller, show me what VFD you're using, what type of VFD is it a 6 pulse, 12 pulse, 18 pulse, what do you got? Because that all changes the harmonic reflection into my system. So I have to get that information and model it in Power Tools. But it doesn't make sense for me to try to provide that VFD for the packaged equipment. We see the same thing on air handling units, where it's a roof-mounted big box air handling unit where with the starters or drives, and typically today it's drives inside. Makes sense for those guys to provide it with that pre-manufactured product, but I need to understand it as we model it.
Can you mark the non-coincidental loads in your mechanical equipment list?
Can I mark them?
You can.
Well, I'm going to be a little careful. We, because of the manufacturing and because of the higher watt density in that computer room, I think we're going to need a chiller all year round.
No, just that's something we have
So
to do.
sometimes that can be non-coincidental. I don't think. So the chiller's going to probably be an annual year-round load, and you know, the boiler. In reality, they're going to have processes that need high hot water for their manufacturing and process load. So the boiler's probably year-round, which is again another one that you might have thought was non-coincidental.
Well, Guy, I mean, would they take the full capacity of the 545 in the winter? That's because if we add this one, I mean, ultimately,
Well, your peak
largest
load's
load-
going to be summer.
yeah, it's going to be summer anyway.
So
it's not
I
gonna make a
guess
difference.
it's going to be summer,
Yeah.
and the chiller probably won't work quite as hard in the winter.
Yeah.
But
It really,
we're going to have some boiler load in the summer, and
but if you look at the boiler load, it's really nothing. It's just, it's just
Right.
120 boiler.
I think what I assumed, and maybe I could have made this a little more complicated, because I don't think I have a big electric element down here for heat. I don't think.
If you have some
Duality.
heaters, just heaters and stuff. Heating units, so that's about it. Yeah.
Well, those could probably be non-coincidental in the
Yeah.
summer load. Yeah, those could clearly be non-coincidental. But what, and maybe what I could have put in to make that more challenging is, as part of my air handler, I could have had supply return fan, and I could have said, you know, I'm assuming we're getting probably natural gas, and it's you know, I didn't focus on how we're getting heat here. But I probably could have, to make this more complicated, say I have a whatever, a 50, 60 kW or 100 kW heating element as electric heat. So I could have suggested we have electric heat, but that's not in here, and at the moment I'm not changing that. So.
And these are year round.
Those are year round. Those crack units. That whatever that is, that 150 watts a square foot. When we get there, that's constant.
And we were talking just before yesterday, Chris and I, about the cooling tower. Cooling tower, it's going to be with the chiller, most likely. It's going to be the largest in the summer anyway.
Right.
So it's not going to make a...
Right. I think one point it just flashed in my mind. On that little sketch I had, keeping in mind, if one PDU goes down, all of that load, of course, goes to the other PDU. So each PDU has to be sized to handle 100% of the load. And the same thing goes for my UPSs. If a UPS fails, all of that load is just instantly on the other UPS. It doesn't skip a beat because both UPSs are feeding and splitting the load. If the other UPS goes down, the load on my surviving UPS doubles right now. I mean, it's doubles. There's nothing switches, nothing transfers, because they're both serving the same load, and if this guy drops off, this doubles. So you have to size the UPSs and the PDUs to handle the total load. Normally they share the load.
You see the term redundant configuration used nowadays? That's what I'm used to in telecom.
Well, in our industry, if I had a full 2N, that's one term that we use. It's a 2N redundant. So I have a system plus system. I have pairs of PDUs. I have pairs of UPS plant. I may have even, I would likely at minimally have pairs of generators. So I could be redundant on the generator. I haven't asked for this, but a typical mission critical data center would have pairs of generators. So I'm redundant all the way through. Oftentimes we're redundant with utility transformers, but the industry, the Uptime Institute really says your redundancy is your 2 gen sets. That's your primary source of power for the data center. So those 2 service switchboards could go to 1 utility, and we'd still be what the industry calls a tier 4, which is the highest level of redundancy for an electrical system. In owner
Could you
equipment.
assume that if it's not listed at the horsepower that it's not a motor? Something like a mechanical equipment list?
Well, let's go up to the top. I think we say horsepower or KVA. So hopefully it's listed. It's either in the horsepower column or it's listed as a load. So if it's KVA, it's sort of the total load at that, you know, for the chiller. Chillers are funny. We don't believe their numbers, you know, sometimes. So we really want to see off of the data sheet what the amps or KVA actually are for that load at the chiller.
And we're supposed to list the motors and take the highest, so you include that in the listing if we are trying to figure out what motors we have. I assume it has a motor. I don't know how it works out.
Well, yeah,
Yeah. So what you're
it's
saying,
basically a motor, so that if it's it's probably, in simple terms, the largest motor. I mean, I'm okay moving it to a motor, but
in the big scheme of things, and I'm sure Guy agree with me, 25% of the largest motor on a project like this, which is 4,000 amp, doesn't make a whole lot of change in the big scheme of things. It really is. When you take
Well,
just
since we're
25%.
organizing and categorizing things, and it's either.
I think that's a valid point. It's
you
either
put
motor or it's
column
not. Yeah.
column B or column C, and I don't care which one it is,
Yeah.
because I know which one is
Yeah.
appropriate to the task.
I mean, some chillers have some peripheral things hanging on, and so, but the motor is probably 95% or greater of the load.
As a matter of fact, if you go to Oracle, first if you go to a 440, that's where the chiller are. It will tell you if you have a chiller with other loads, you take the largest multiplied by 125 of the chiller or the other load and add the rest of it. So you could easily assume the chiller is the largest load and add the rest of them to it.
Yeah. Yeah, let's assume that the chiller, even though I've given you KVA, is a motor. That the trouble is chiller manufacturers play games with KW per horsepower, and of course, depending on your power factor, that translates into KVA. I have to size my wires for the amps and my gensets for both KW and KVA. You know, but they'll say we're 0.65 kW per ton, and of course they're not even necessarily giving me the horsepower. They're giving me the ton of the chiller. And okay, what's the horsepower? Can't find it. It's 746 watts per per horsepower, but then you got to factor in efficiency. There's probably a motor that we could deal with. But why don't we just, for our exercise, we're going to call that load a motor load, and go ahead and use that in your service sizing calcs. Okay. Any questions? I think we've given the boxes a number, and that's what we're expecting as a power drop to that piece of equipment with an appropriate receptacle, and the equipment just kind of plugs in next to it.
What we have done in the past, Guy told him that to assume these are continuous load here and just multiply it by 1.25 to size the overcurrent.
Yep.
Overcurrent protection device and conductor.
Yep, I think that's fair. I mean, I've given you what I think is it's running amps.
So that's,
And we're just going to assume that it could run continuously at that point. You know, obviously it probably doesn't all the time, but we better be prepared for it to run, and we'll treat it
the
as
question came
load.
from Chris is would we treat them like motors? These are, because if you treat like motors, you have to size the overprotection device 2.5, or, you know, I always multiplied my 1.25 and size overprotection device, but
Well, you don't have to size by 2.5. You're allowed to size at 2.5 for a motor. I mean, you could, if it's a piece of equipment, we could size it at 125%.
Yeah.
Well, there's an 80% demand factor, so there's the gate.
Yeah. Let's, and maybe that contradicts what you've, I mean, have some, I'm open to you fine tuning this.
Okay.
And
But we're talking about here about the SO ports that we're sizing to tie to the equipment, not the service. With the service, the demand and the continuous will cancel each other.
yeah, that's true. So what I've said is you could apply the demand as we collect those loads back at the next level and going further up. But I want that branch circuit just as Chad has said at 125%. Minimally times that continuous load.
So we'll do the S ports that you tie to the bus ducts.
Okay.
And that was always, when we do 120, I was assuming we're giving it a neutral here, that machine? Or
Yes.
Is that
So I would be looking at a drop that has a receptacle that has a neutral in it. So it's a, probably a 5-wire drop if we got, well, that's a single phase. No, it's 3-phase. So it's probably a 5-wire drop. 3 phases, neutral ground to a receptacle that'll accommodate the 5-wire with that amperage config. Okay. One thing I mentioned at the project presentation, and I don't really say it in here, and it looks like you folks do it to some degree anyway, is modeling this project in Revit. And I brought that up, that if you're going to do this project in Revit, work towards creating a model. And the Revit model, could show the light fixtures at the ceiling plane and things of that sort. Probably receptacles and walls. And I've seen some Revit modeling done, but I don't know if it's been a requirement to completely do the Revit model. I'm going to kind of let you, Chad, guide that, but I would like to, if it's possible, to at the end of the day, if there's a chance to see a Revit model.
I think Phil is working on exporting it to, what software are you exporting it to?
Navisworks.
And maybe we'll do walkthrough for Navis, but we haven't really been,
Okay.
especially in the commercial.
Well, that's something I'd like to see, but I mean, you have a better idea of what can be done with the time given, so maybe that's an extra credit thing or something.
The limit is really the sky. There's so much you can do out of it.
Right.
The challenge is we just need to first hit the required stuff.
And maybe when we get into power tools, there'll be some folks that really want to dial into power tools, want to do a
Yeah.
harmonic analysis or something great like that. But
Yeah.
not that much interest in creating a Revit model, but glad we love to dive into into power tools to the nth degree. So.
Does the architectural model have the appropriate ceiling
No.
articles to attach? Because you can't, if you have the lights and you're doing the model, you have to attach something that exists in the architecture.
Unless someone's redrawn this in Revit, the one that we provided was probably AutoCAD 12, originally. So I don't know how it's been updated. If your folks have redrawn it in Revit, I didn't give you a Revit.
Yeah, I know.
Architectural.
The model is good enough to do a lot of stuff on it. We have the ceiling to put. There's monkeying around because we have two-story building, especially the manufacturing space, because the floor goes all the way to the second. So when you put your fixture, if you put them in the first floor, they would show on the second floor because the ceiling goes from all the way through the second.
That's probably where they should show on a Revit model.
Yeah,
if,
so there
if
was
they're
monkeying
in the
around.
manufacturing space,
Yeah.
unless you say that they're mounted at whatever, 12 feet or 14 feet from the
Really
floor. If it knows it's mounting from the floor, then it should be there, right?
Yeah. That was the hardest thing, is the open space. It's just a Revit issues.
Okay. Well, that's just something that I had talked about that I would like to see, but Chad, you decide what's going to be a requirement or not for the coursework. Any other questions on the project? No. Some of you have met Phil Ortson in our office, and he would be here more than I will be here during the course of this project. And Chad, you've really kind of taken control of a lot of the details that we, in the past would provide. So if there's something unique that you want us here, we'll be here. If you've got it under control, we won't. So we'll kind of play it week by week. I do have Brad Nelson coming in tomorrow.
Okay, that's
at
good.
9.
Yeah.
9 o'clock, 9 to for about 2 hours.
It's always be good. Yeah, as I think, am I right, guys? Is the more Revit we can dig into, the better. We have Mishad has experts in Revit, and the more we can get people to talk a little bit, take Revit to the next level, the better it will be. Any other help? That's the only thing I can think of. I know the project is still at the beginning, and you want to say a few things about the trips that we do, Guy? And there's a lot of field trips.
Yes, and I think they're very important, and these folks have given up time and made these tours. They've opened up their doors for these tours, so I think it's great to take advantage of that. And unless there's some dire conflict, I'd strongly recommend that you participate in all these tours that would be coming up. And of course, there's some in classroom instructions that's coming up. But as I look this over, the Boston Scientific, which is on April 5th, again, that one you're going to really kind of see a medical manufacturing facility. So that really give you a flavor of what this building was modeling in a sense. So I kind of carved out some pieces of Boston Scientific to create this project here. And then there's a lighting presentation by Mike Brayback at Industrial Lighting. I think is good, very good. Then lighting protection folks, Doug Franklin's coming in, and he'll really help you out. I see you've got some time at the expo, so that's always a good thing to attend. The Cummins presentation on the 24th is showing, and I think there's 3 large medium voltage gen sets that parallel with the utility. So they parallel the gen sets, and then they can parallel the gen sets with the utility. But if you want to really dial into some of these issues and questions, the Cummins folks will have capability to to really answer any questions you might have in that regard. So that's a great presentation that really speaks to what we're asking for here. And in the EMI tour, May 1, EMI is a custom shop that builds switchgear. You know, we're all familiar with Square D, GE, Cutler Hammer, or now Eaton. I mean, those guys are big in the nation, but EMI is a local specialty gear manufacturer, and so you'll be able to kind of walk through their shop and see what they have going on. And it's always a good to see hands-on some of this equipment.
Where are they located?
I think out in Plymouth. I think so, yeah. I've been there a couple times, but I think it's out in Plymouth. And then May 8th, the Allianz tour, we get a chance to see some office space. We get to see their data center. It's a project that we worked on a number of years ago, and they've been kind enough to let us go through. It's just a good project to look at. We do have a chance to go through their main electrical room, and we can see how we treated the office switchgear separate from the data center switchgear. You kind of get a flavor of the differences of what we've used. And again, you've got some folks coming in to talk, and let's see, there's one. Where's ours?
It's week 9.
Week 9. Okay, yeah, you don't miss that. Tour of our office, and Todd will just kind of do some higher level talk of power tools. You'll probably have been exposed to it by then, but he can show you a little bit more of what we do that may go beyond the things you've done for this class. Okay?
Then you're going to be here for project
Yeah,
management.
yeah.
And I think Dave is going to be here for estimating.
Yes.
So that will be really good.
And it's titled Project Management. We'll get to that at the end of May, but what I tend to talk about at that presentation is, you know, what is your life as a graduate from this program, more from an electrical consulting engineer's perspective, coming into our office, working your way through, and eventually talking about project management. But we've never hired a project manager out of this class directly. There's some training and there's some time it takes to become a project manager. So I want to kind of spell that out, go through that at that meeting in May. Any questions? Any more questions? Yeah? No? No? Okay.
It's like an auction. You can't raise your hand.
Sold. All right.
All right. Thank you so much.
Very good. Thanks.
Thank you, Dave.
Do a couple of clicks here.